friends, this is Jenny. Welcome to my YouTube channel. Today we are going to see about sorting in data structure. Before that, subscribe my YouTube channel, click a bell button to get further updates. What is sorting generally? It is a process of ordering or arranging something like element in a particular order. In numbers, we have ascending and descending orders. What is sorting in data structures? It is like slightly different from general order. Here we are considering data. Here it is the arrangement of data in a preferred order. In this video, specially and particularly, we are going to find which method is best among all the methods. Selection sorting. It repeatedly selects the smallest or largest element from the unsorted portion of the list and swaps it with the first element of the unsorted pot. This process is repeated for the remaining unsorted portion until the entire list is sorted. Let's consider this example array of 59, 42, 11, 13, 75. Step 1 of first pass. First element is 59. It will be replaced by the smallest element. The smallest element is 11, which position is index 2. The index 2 value is replaced by index 0's value. Then index 0's value will go to index 2. Like that, it will continue to whole unsorted list. Second pass, like 13 will come to index 1 and 42 will go to index 3. Third pass, like 42 will come to index 2 and 59 will go to index 3. Fourth pass, like here fourth position is having correct value. Fifth pass, like fifth position is having correct value. So it will get sorted like this. Advantages. It is simple and very easy to understand and works well with small data sets. Disadvantages. If it works fine with small set means it won't work well on large data sets. Does not preserve the relative order of item with equal keys, which means it is not stable. Main disadvantage is time consuming, like time complexity. It will take two nested loops O of n squared. First loop to select an element of array 1 by 1 is O of n. Another loop to compare that element with every other array element is O of n. Therefore, overall comparability is O of n multiplication O of n is O of n star n is O of n squared. This is the problem with it. Bubble sorting. It is a basic algorithm for arranging a string of numbers or other element in the correct order. It is the simplest sorting algorithm that works repeatedly swapping the adjacent elements if they are in the wrong order. Let's take this as example array of 7416. Step 1 or first pass is like in index 0. It will compare first value with second as adjacent one. Here it is 7 and 4. Here 7 is big, so it will go to the right hand side. Next is index 1. Here 7 and 1. 7 is bigger, so it will go to the right hand side. Same will happen until the bigger one will go to the last index. Like step 1 will continue until it's sorted completely. Finally, it's 1467. Advantages. It is easy to understand and implements. It does not require any additional memory space. It is a stable sorting algorithm, meaning that elements will the same key value maintain their relative order in the sorted output. So when comparing selection sort, it is stable. Disadvantages. It has a time complexity of O(n) squared like selection sort. It is a comparison based sorting, which means that it requires a comparison operator to determine the relative order of elements in the input data set. So it can limit the efficiency of the algorithm in the certain cases. Can't use it for large sets. Insertion sorting. It is like playing cards in your hands. The array is visually split into a sorted and unsorted pot. Value from the unsorted pot are picked and placed at the correct position in the sorted pot. Let's take this as example. Array of 15, 12, 14, 7, 8. First pass. Initially, first two elements of the array are compared. Here 15 is bigger than 12, so it is not in ascending order. So swap 15 and 12. So now 12 is sorted in sorted subarray. It will continue to until gets sorted completely. Finally, it's 7, 8, 12, 14, 15. Advantages: simplest to implement, efficient to small data values, having adaptive nature, that is, it is appropriate for data sets that already partially sorted. Disadvantages: time complexity O of n squared, same as previous two types, not suitable for big data. Merge sorting. It divides an array into smaller subarrays, sorting each subarrays and then merging the sorted subarrays. Let's consider an array of 38, 27, 43, 10. First divide the array into two equal halves. These subarrays are further divided into two halves. Here, after that it is can't be divided. If it is a longer array, then it will be a very big process. These sorted subarrays are merged together. Then this process will continue until get completely sorted. Finally, it's 10, 27, 38, 43. Advantages: merge sort. It is a stable algorithm maintained relative orders in the input array. It has a worst case time complexity of O of n log n, which means it performs on even large data sets. It is naturally parallelizable algorithm. Adapted for all, like partially sorted, nearly sorted, or completely sorted. Disadvantages: merge sort requires additional memory for subarrays. It can be a disadvantage in applications where memory usage is a concern. It will take time for smaller data sets because of its time complexity. Quick sorting. It is a divide and conquer algorithm. The key process is quick. Short, it is a partition. The target of partition is to place the pivot at its correct position in the sorted array and put all smaller elements to the left and all greater elements to the right of pivot. Partition is done recursively on each side of the pivot after the pivot is placed in its correct position, and this finally sorts the array. Choice of pivot. Always pick the first element as a pivot, or always pick the last element as a pivot, or pick a random element as a pivot. Pick the middle as a pivot. Let's consider of array 10, 80, 30, 90, 40. First, compare 10 with the pivot as it is less than the pivot. Keep it there. Next, 80 is bigger than pivot, so keep it there. Next, 30 is smaller than pivot as well as 80, so swap it. Next, 90 is bigger than pivot, so swap pivot with 80. So sorted finally 10, 30, 40, 80, 90. Advantages: easier to solve problems, efficient on large data sets, require small memory space. Disadvantages: it has O of n squared time complexity, so pivot chosen will be poor, not suitable for smaller data sets. Not a stable sort. Here relative order will not be preserved in the sorted output. So at last we came to final discussion. After seeing all the advantages and drawbacks of all the types, sorting method is quick sort because it works to a big data. Efficient requires low memory space. Stable method is merge sort but requires large memory for subarrays. Best for smaller sets. Bubble sort or it's stable. Everything is the best in its way. Thank you for watching, guys.